Welcome back to Code Wonka. Today we will be solving merge intervals problem. Let's go over the question. Given an array of intervals where intervals of I is equal to start of I, end of I, merge all overlapping intervals and return an array of the non-overlapping intervals that cover all the intervals in the input. Let's take this example test case to understand the problem. The expected output will be this. If we were to put these input intervals on the time axis, then they would look like this. On this time axis, we can see that 1,3 interval and 2,6 interval has some overlapping time. Hence, these two intervals are merged into one interval in the first element of the output array, that is 1,6. From this example test case, we can draw this observation that when the interval is sorted by start time, as you can see on this time axis, then finding overlap of intervals is comparison between the current interval and the immediate next interval by start time. Once we find the interval, then we can merge these two intervals by choosing the start time as minimum start time of the current and immediate next interval. In this case it would be 1, and choosing the end time as the maximum end time of current interval and end time of the immediate next interval. In this case it would be 6 in the output. From the observation we can come up with this intuition. The first step would be to sort the input array. Next step would be to iterate the intervals in the sorted array and identify overlap by comparing current interval with the previous interval. Next step would be, once we have found the overlap, then we will merge the two intervals in one by using this merge operation. So let's start the solution visualization. We start by sorting the input intervals array by start time, and we initialize merged variable to empty array. Then we initialize the red pointer to the first element of the sorted array. Since the merged array is empty, so we append the red pointer element in merged array. Now merged array has an element, so we initialize blue pointer to the last element in the merged array. We increment the red pointer to the next element. We check if there is overlap between the red pointer element and the blue pointer element. Yes, there is. So this overlapping condition, where we check that the red pointer's interval start time is less than equal to blue pointer's interval end time, it will be true. Since overlap condition is true, so we will perform a merge operation. In merge operation, we choose the bigger element of red pointer interval end time and blue pointer interval end time. So we will choose the max of 6,3. 6 is bigger end time, so we override 3 with 6 in merged array. We increment the red pointer interval to the next element. Now there is no overlap between the red pointer interval and blue pointer interval, so the overlapping condition will be false. Because overlapping condition is false, so we skip the merge operation. We append the red pointer element to the merged array and set the blue pointer to this newly appended element in the merged array. We move the red pointer to the next element. There is no overlap between red pointer interval and blue pointer interval, so the overlapping condition will be false. We skip the merge operation and append the red pointer element to the merged array. We set the blue pointer to this newly appended element in the merged array. Red pointer reached the end of the interval. So now merged array is the expected output and we return the merged array. Let's code the solution. We start by sorting the intervals array by start time of individual intervals, that is the first element of inner array. Then we initialize merged intervals array with first element of sorted interval array. We then write a for loop to iterate each interval in sorted intervals array. Then we extract the start time and the end time of the current interval. These variables current start and current end were represented as red pointer in solution visualization. Next, we extract the start and end time of the last element of the merged interval array. These variables were represented as blue pointers in solution visualization. Next, we write the overlapping condition in this if statement. If the overlapping condition is true, then we perform merge operation by setting the interval end time of merged array to max of previous end, current end. Else we will skip the merge operation and we will simply append the current interval to the merged intervals. At the end of the loop, we will return the merged intervals array. Let's do a complexity analysis of the code. The sort statement at line 3 has a time complexity of n log n and space complexity of O of n. Then we have this for block that has a time complexity of O of n and space complexity of O of n. So the overall total time would be n log n because of sorting, and the total space would be O of n because of space by merged intervals array and sorting. If this video helped you in learning, then please like, subscribe and share. Leave your feedback in the comment section. Thank you for watching this video and stay tuned.